How do we get to add the two matrices? Remember what we have said here is that a matrix is an array of numbers that are enclosed in a pair of what here? Brackets. Under matrices here, we must be good at these matrix operators. Matrix operators are 4. We have the addition, we have subtraction, we have multiplication, and then number 4, we have inversion. So ladies and gentlemen, I would want us to do these two just by using this small example. We are given two matrices A and B, and then somebody tells us to go ahead and add them. So A plus B, remember for matrix addition, we normally add corresponding elements. We normally add corresponding elements. Like now these 3 and negative 8. They are first elements of their respective matrices. The first elements, you combine them. So we have here 3 plus minus 8. 3 plus minus 8, that will give us minus 5. And then we have the second elements that are corresponding. So we have 8 plus 6 giving us what here? 14. 8 plus 6 gives us 14 there. And then we have the third element. So we have 2 and the 4. When you consolidate them together through addition, 2 plus 4 will give us 6. And then we have 7 plus minus 3. 7 plus minus 3, that gives us what here? That gives us 4. That gives us 4. That gives us 4. And that is it as pertains what here? Addition of matrices. So addition of matrices really is not a tough thing. It's not a tough thing. It's not a tough thing. What if, my great student, somebody comes and tells you to subtract these two matrices? What if somebody was to tell you to subtract the two matrices? How will you be able to subtract these two matrices? If somebody tells you to come and subtract A minus B, what will we get there at the end of the day? Just like for the case of addition, again, we subtract corresponding elements. We normally subtract corresponding elements. So corresponding elements, like now 3 minus, there's this minus. So we have 3 minus 8. So 3 minus 8, that will give us what figure, somebody here? That will give us 11. That will give us 11. From there, ladies and gentlemen, we have here 3 minus 6. 3 minus 6, that will give us minus 3. And then we have here 2 minus, this minus, 2 minus 4, that will give us minus 2. And then we have 7 minus 3, that will give us 10. Is there anybody who has any question regarding addition and subtraction really? Addition and subtraction, before I go to the past papers as Benjamin advised us to do. So ladies and gentlemen, once I have understood addition and subtraction, we can go straight away to the next thing, which is the multiplication. And the multiplication is the most important thing, most important operator, because you can't know the Markov concepts if you don't know how to multiply two matrices. You can't know that. You can't know that. So matrix multiplication is very, very important. Now, ladies and gentlemen, if you are given two matrices here to multiply, you are given two matrices here like 3, 2, 8, 1, 1, negative 2. You are told to multiply here with 6, 9, 4. We have 5, 3, 2. 5, 3, 2. You don't even have to assess these matrices for compatibility. What you need to do, ladies and gentlemen, is straight away to multiply your matrices. Please go ahead and multiply these matrices. And how do we multiply matrices? We'll use what we call Roman. We'll use what we call Roman Catholic. In multiplication, we normally make use of Roman what here? Catholic. Roman for rows. Catholic for columns. So in short, we are saying that rows will be multiplying what here? Somebody will be multiplying columns. To put it better, rows of the first matrix will multiply columns of the second matrix. Rows of the first matrix, rows zinaenda namna hii always, Column ni kama columns za nyumba zinasimama hivi, like that. So I'm repeating again. I'm saying that the rows of the first matrix will multiply the columns of the second matrix. And how do we get to do this operation? Ladies and gentlemen, remember what we used to say in high school. You run down the ditch. You run down the ditch. So as you're using the rows, like you're running like that, once you reach it, you jump down the cliff. Listen and listen to me very well. To do my multiplications very well here, what I will do, I will come and say I'm using this row by first column. So how am I doing it? First ones multiplied, plus second ones multiplied, plus third ones multiplied. Right? Remember, Roman Catholic, a row and a column has to give me only one figure. A row and a column must give me only one figure. And to ensure that I'll get only one figure, I must keep on doing what here, somebody? Adding the resultant multiples. So the first ones multiply, this will be 3 times 6, plus 2 times 9, plus 8 times 4. And then, of course, we don't write that procedure down. We only do it with one stroke in our calculator, and we should be able to get the multiple. Can somebody help me out here? Somebody help me out here. Who is able to get this consolidated figure at once? This consolidated figure at once, who is able to get it? The consolidated figure at once, who is able to get that figure? Somebody. Aha, somebody HP man, Denise here. They're able to give me 68. They're able to give me 68 like that. Listen and listen to me very well. When it comes to matrix multiplication is a beautiful thing. Very beautiful thing. Very beautiful thing. What I will do under matrix multiplication, like after I have done this row with this column, the same row has to multiply the second column. This row has to multiply the second column. And how will we multiply them out? The same concept, you're running down the ditch. And how do you do it? First ones multiplied, plus second ones multiplied, plus third ones multiplied. And then you give me an answer. So first ones multiplied, we have 3 by 5, plus 2 by 3, plus 8 by 2. You give me an answer. HP man is able to see 37. 37. Is there anyone else who is able to get that 37? Yeah, a bit Gorang is also giving me the same. And these answers here should come from all of us. All of us. These answers here should come from all of us. All of us. Kiprotich is also getting the same. 37. Thank you and thank you very much. Ladies and gentlemen, we are through with the row number 1 of the first matrix. It has done the necessary. It has been able to multiply the 2 columns of the second matrix. Now we get hold of the second row. This second row with the first column. The second row with the first column. I want to see whether there are some new students who haven't spoken yet, who can give me the answer for this row and the first column. Remember, it is a step of faith, some confidence level. How do we do it? First ones multiplied, plus second ones multiplied, plus third ones multiplied. It is Roman Catholic. So first ones is 1 and 6, plus second ones 1 and 9, plus third ones minus 2 and 4. Somebody is giving me a figure of 11. Unfortunately, is it 11 or 7? Denise, check out. 7 seems to be carrying the day. Thank you very much. Edward has come on board. I'll be very happy to see Dahir getting, even Mohammed. Yeah, Mohammed, thank you very much. Mohammed has just joined us and he has been able to post something very fast. Very fast. So they are telling me that the correct answer is supposed to be 7. The correct answer is supposed to be 7. From there, I will come and pick this row with the second column, this row with the second column. Don't write that particular procedure down. So long as even where you're sleeping, you'll be thinking about first one's multiplied, plus second one's multiplied, plus third one's multiplied, and then you give us an answer. So can somebody help me here? Somebody help me out here. Help me out here, somebody. Help me out here. And then remember, as you're doing this, there are those special topics that you guys feel that we need to either go back and do them as per your course outline, or perhaps you even never did them as per your course outline. It's important I get to know them. You can either post them here, or you post them in our WhatsApp group, or you post them in our WhatsApp group. So the last one, what answer do we have? Somebody, I'll not even before 4. Benjamin Munyoki tells me it's 4. Mohammed is confirming that 4. Kiprotich is confirming that 4. Denise, the same. Thank you and thank you very much. Thank you and thank you very much. Abit Garang, the same. So is there anybody who has a question before I leave this particular operation? Before I leave this particular operation. Is there anyone who has a question? Is there anyone who has a question? Is there anyone who has a question? That is in order. It's in order now. So now that beckons for only one more operation, and we are out of that concept, what we call inversion. Inversion. So we have here inversion. If you can remember, inversion, ladies and gentlemen, inversion is applicable to square matrices. There is no way you can inverse a matrix which is 2 by 3. Inversion is an operation which can only be executed when you have a square matrix, the smallest square matrix being a 2 by 2. And our syllabus tells us to show you how to inverse a 2 by 2 matrix and a 3 by 3 matrix. So I want to show you how to get an inverse over a 2 by 2 matrix first. How to get an inverse over a 2 by 2 matrix. Inverse over 2 by 2 matrix. Now, ladies and gentlemen, listen and listen to me very well. If you're given a matrix of this nature, 3, 2, 6, 8, and then somebody tells you to find the inverse. You find the inverse. How will we be able to find the inverse of this matrix? First of all, I must know the order of this matrix. This is a matrix that has got how many rows? That has got 2 rows. These are the 2 rows like this. And the columns are how many downwards? Columns are 2. So it's a 2 by 2 matrix. And indeed, if this is a 2 by 2 matrix, the thing that I need to do is to appreciate the 2 steps method. To appreciate the 2 steps over analyzing an inverse over a 2 by 2 matrix. So these 2 steps are very clear and easy to understand. The first step being you ascertain the determinant. You ascertain the determinant. And remember that our determinant is normally symbolized like that. A with these 2 parallel lines. You ascertain the determinant. Who can remind Mwalimu the formula of getting the determinant? Who can remind Mwalimu the formula of getting the determinant? So kindly help Mwalimu. How do we get the determinant? 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 I'm waiting for that student who will be able to give me the formula of ascertaining the determinant. How do we get the determinant? Determinant. Thank you very much, Lokai. Lokai, indeed. Lokai, she happens to be good in this. So Lokai has told us something very easy, that to get the determinant, what we only need to do is to take the product of the primary diagonal minus the product of the secondary diagonal. Please write that in full. The determinant equals product of primary diagonal minus product of secondary diagonal. Product of primary diagonal minus product of secondary diagonal. I can see Benjamin has also remembered that formula very fast. Even Dionysius. To get the determinant, we normally take the product of the primary diagonal minus product of the secondary diagonal. And if you can remember from those good days, old days when you were in high school, this used to be the primary diagonal. The one that starts from the first element, the first angle here is what we call the primary. The other one, we call it the lagging or the secondary. So the same case with our square matrix, ladies and gentlemen. The same case with our square matrix, ladies and gentlemen. This square matrix has got the primary there. The square matrix has got the primary. So the primary diagonal is that diagonal that starts from the first element. That diagonal that starts from the first element here of the entire matrix, which is 3 times 8. Therefore, ladies and gentlemen, this will be 3 times 8 minus product of secondary diagonal. Product of secondary diagonal, you must always put the secondary diagonal into perspective. The secondary diagonal elements must always be put in brackets. So product of secondary diagonal, what do we have? We have 6 times 2. 6 times 2. So could you kindly give me this answer? Kindly give me this answer. Kindly give me this answer. Product of secondary diagonal must always be put in brackets, especially whenever you have one or all the elements inside the secondary diagonal here being in, for example, negative. Negative. So could you kindly give me an answer here? What is our determinant? What is our determinant? Abracadabra. Abracadabra. According to Benjamin Munyoki, we have 12. We have 12. 12. Mohammed has been able to confirm this figure. Mohammed has been able to confirm this figure. Ladies and gentlemen, having appreciated that the determinant is at 12 there, what I need to do is to go to the next step, which happens to be the last step. The last step is what we call the inverse definition. The inverse definition, ladies and gentlemen, what we have over here. The inverse definition, what do we have over here? Inverse definition, we normally write it like this, a raised to minus 1. Whenever you see like a letter a raised to minus, that's an inverse of a, or b raised to minus 1, that will be the inverse of b. So ladies and gentlemen, the inverse of a here will be equal to what? It will be equal to 1 over the determinant. Here I would want to really stress something, that anytime you want to inverse, you will start by giving us 1 over the determinant into brackets. Here, what do we do in brackets? Inside the brackets, ladies and gentlemen, the very first thing that I will never forget, inside the brackets there, we shall always swap the primary elements. So the primary elements, what do we do with the primary elements? Always exchange them. In these brackets here, the primary elements, you always do what here? You always exchange them. You swap. These are the primary elements. So we swap them. They'll take their, or rather we have their respective positions there. Of course, in this case here, we interchange them in between their respective positions, yes. So we have here 8 taking the position of 3. So we have 8 there and 3 taking its position, 3 like that. Now listen and listen to me very well. For the secondary elements, we shall leave them in their respective positions, but we have to change their signs. What have I said, ladies and gentlemen, for the secondary? For the secondary elements, we shall leave them in their respective positions, but change the signs of the secondary elements. So these secondary elements, we shall leave them where they are, 2 and 6. But now we have to change the what here? We have to change the signs like that. They were positives, now they become what here? They become negatives. They were positives, now they become negatives like that. If you allow Mwalimu, straight away Mwalimu would want to give you one question of this nature, you try it out. One question of this nature, you try this out. So I want to rub this and give you a question that I would want you to try, a question that I would want you to try. And this is the question. If you're given here A, you're given A equals -3. Then we have -2. Then we have 6, ladies and gentlemen, and 8. And then somebody tells you to find the inverse of this particular matrix. Find the inverse of this particular matrix. Find the inverse of this particular matrix. Who will be able to help me in a minute? Just 1 minute like this, 1 minute only. Please give me the inverse. First of all, start by giving me the determinant. First of all, start by giving me the determinant. I like this. I like this because under topic number 1, you can't miss at least one question. This is a savior area. It's a savior area. Savior. It can really save you. It can make you see places that you've never seen before. It can make you see places which you have never seen before. So my friend Melchiora Pemo gives me -12. Also, we have Benjamin getting the same. Lokai also has gotten the same. Mohammed the same. What those students have remembered in this first step of getting the determinant, the formula is PPD minus PSD. Product of primary diagonal minus product of secondary diagonal. So the primary diagonal moves like this. So the primary diagonal is -3 times 8. And then minus the secondary diagonal, please. So many students get it wrong here because they forget putting the secondary elements in the respective brackets. So we have here open brackets for the secondary. Remember, the primary diagonal elements are these elements, ladies and gentlemen, that we have here in the leading diagonal. And remember, the primary diagonal is the one that starts from the first element of the entire matrix. And then the other diagonal will be the lagging. So the lagging, we have -2 by what here? By 6. So could you kindly give me an answer at the end of the day? What do we have here? At the end of the day, what do we have here? At the end of the day, what figure do we have? Is that -12 correct? Is -12 correct? Yes, -12 is very correct. -12 is very correct. Now, ladies and gentlemen, having gotten the determinant, the next thing I know my students will tell me is to go ahead and define the inverse. And how do we define the inverse? To define this inverse, these students of mine are so good. They know it is 1 over the determinant that you've just given me, 1 over -12. Into inside brackets, ladies and gentlemen, we shall, inside brackets, ladies and gentlemen, we shall do 2 things. The first major thing being the interchange, the exchange between the primary elements. So the primary elements here we shall exchange. So we have 8 versus -3. The primary elements, we exchange them. And then the secondary elements, ladies and gentlemen, we shall leave them where they are, but change their signs. We shall leave them where they are, but we change their signs. So we leave them where they are, like this was either 2 negative, now it will have to become positive. This earlier on, you can see it was a positive figure. Here now it has to become what here? A -6. Ladies and gentlemen, that is the end of this, and we do not have to spread the scalar inside. No, we just leave it like that. And that is the end of that particular inversion over a 2 by 2. So that we don't make reference again to this in the near future, let's come straight away to how do we use this particular concept, ladies and gentlemen, to solve simultaneous equations. To solve simultaneous equations. How do we make use of these to solve simultaneous? If you're given an equation like this, x plus y equals 5, and then somebody speaks of 2x minus y equals 1. 2x minus y equals 1. 2x minus y equals 1. So you're given these 2 simultaneous equations, and then somebody tells you to solve for x and y. You solve for x and y using the inversion method. So solve for x and y, using inversion method. using inversion method. Solve for x and y using inversion method. Using inversion method. So inversion method is a straightforward method, very straightforward. I will not even bother to think about this so much because inversion is as easy as reading out the ABC, alphabetical letters, or just as easy as a walk in the park. Remember, for us to be able to get the unknowns, we normally take the inverse of A, the inverse of A. The inverse of A multiplied by what here? The right-hand side values. The inverse of A multiplied by right-hand side values. Multiplied by right-hand side values. Remember, these are the right hand. These are the right-hand side values. Those are the right-hand side values. Now, ladies and gentlemen, X is the unknown. X represents the unknowns. So, and in this particular case, what does A stand for? A stands for what we call the base matrix. A stands for what we call the base matrix. A stands for the base matrix. The base matrix is this matrix that you shall get out of here. Is that matrix that you shall get out of there. So what we need to do very fast, ladies and gentlemen, is to define our matrix A. Come here and define matrix A for us. Matrix A is that matrix of numbers, of coefficients that come before these letters. So before the letters we have 1, 1. Here we have 2. Please don't forget here and just pick one alone. A negative sign before a number is always part of that number. So like now this one here should be minus what here? Minus 1. So that is our matrix A. Having spelled it down that nicely, I know for sure that the next thing will be to inverse it. And there is no way I will be able to inverse this matrix without ascertainment of the determinant. So please go ahead and give me the determinant. Go ahead and give me the determinant, and as such. So what we have here, once, ladies and gentlemen, once you have given me this matrix, to inverse it, the first thing that I'll do is to come and ascertain the determinant. Give me the determinant of A. How do we get the determinant of this matrix? It's very easy. To get the determinant here, I need to take the product of primary diagonal minus product of secondary diagonal. So product of primary, we have 1 times minus 1. Minus product of secondary. Product means you're multiplying. So 2 times 1. Please, you can avoid brackets here for the primaries, but secondary, you must always put brackets. So could you kindly give me this figure? Give me this figure. What is our determinant? Somebody help me out. According to Kiprotich, this determinant is supposed to be minus 3. According to Kiprotich, the determinant is supposed to be minus 3. And once you have spelled the determinant down that nicely, what you need to do is to come and give us the inverse of A. So the inverse of A is pretty easy to get. How do we get it? You'll come and talk of 1 over the determinant into, get inside the brackets and do your abracadabra there. So inside the brackets here, what are we doing? We are interchanging the primaries. So the primaries, we have minus 1, we are interchanging them. So minus 1 versus 1. And then we have the secondaries, we leave them where they are, but we change their signs. What have we said about secondary? Secondary, we shall leave them where they are, but change their signs. So we have both of them were positives. So here, both of them will be what here? Negatives here. Now, ladies and gentlemen, that is our inverse of matrix A, the inverse of the base matrix. Inverse of the base matrix. Now, having gotten the inverse of the base matrix, what we need to do is to come right away and apply our formula of capital X. Our formula of capital X. Don't forget our formula of capital X. How do we use our formula of unknowns? We have our X being equal to I minus A inverse multiplied by what here? The right-hand side figures. So we have our X here being equal to 1 over minus 3 into minus 1 minus 1 minus 2, 1 multiplied by the right-hand side values which are here, 5 and 1. Ladies and gentlemen, what I will do is to come and leave the scalar out first. I will leave the scalar out first so that I give preference to multiplication of what here? 2 matrices. We multiply these 2 matrices. When it comes to multiplication of a matrix, that is an easy thing. I will use what we call Roman Catholic. I will use what we call a row multiplying a column. I will use what we call you run down the ditch while multiplying. And how do we do this? The first elements to be multiplied plus the second elements multiplied. And then you give me one answer. Because run down the ditch should always give us a consolidated one figure. So we have minus 1 by 5 plus minus 1 by 1. Could you kindly give me a figure? Kindly give me a figure to write here. Kindly give me a figure to write here. So somebody gives me a figure of minus 6. Minus 6. How about this other figure? Remember, this row will multiply the first column. And then this other row as well will come and multiply this column. How does it multiply this column? We have minus 2 by 5 plus 1 by 1. And then you give me an answer. You give me an answer. We have Kiprotich. We have Melchior giving me negative 9. Ladies and gentlemen, it's after we have done such a nice job that we now need to come and use what we call the distributive law. Distributive law. And distribute this scalar to each of the members here. You distribute to each member here the scalar. Therefore, we are saying the first unknown is X. So X will be 1 over minus 3 times minus 6, which I'm being told is 2. The second unknown is Y. Y, I'm using this same scalar, 1 over minus 3 times minus 9, which will end up giving me what figure? Somebody there? Which will end up giving me 3. Yeah. So a good student is asking, Mwalimu, which topic is this? We are simply now doing a major review of our syllabus. We are doing a major review of our syllabus, and this happens to be what here? This happens to be matrices. Matrices, a topic that we began just now, and we should be able to finish it immediately. Now, ladies and gentlemen, remember, at times your examiner could also tell you to use what we call the Cramer's rule. Your examiner may tell you to use the Cramer's rule. So if you're told to use Cramer's rule, if somebody tells you to use Cramer's rule to solve the above simultaneous equation, if someone tells you to use Cramer's rule to solve the above simultaneous equation, how will we do this? The first thing that we'll do under Cramer's rule is to identify the base matrix. Identify the base matrix. We say the base matrix is the one that has got which coefficients? Coefficients of X and Y. So coefficients are those numbers that come before those letters. So the base matrix here will be this coefficient. We have 1, 1. And then we have here 2, minus 1 like that. Now, ladies and gentlemen, the moment I've been able to define my base like that, I will go straight away to the next step, which is the one of ascertaining the determinant. So go ahead and give me the determinant. Go ahead and give me the determinant. Remember, determinant is product of primary minus product of secondary. Determinant is product of primary, so 1 times minus 1, minus product of secondary. Secondary, I can see it is 2 times 1, which if I remember very well, the teacher had given me a figure of minus 3. Minus 3. Minus 3. Now, ladies and gentlemen, having gotten the determinant, how do I make use of the Cramer's column rule? Cramer's column rule. The Cramer's column rule. Very easy. The Cramer's column rule, this is quite an easy thing to be done. The Cramer's column rule is quite an easy thing to be done. Ladies and gentlemen, remember that under Cramer's, this column has a special name called what? Replacement. Replacement. This column has a special name called replacement, such that if you want me to give you the value of x, I will come and talk over, listen and listen to me very well, two things. I'll be having the numerator matrix divided by determinant of the base, divided by determinant of the base, divided by determinant of the base. So if they want me to give them, I wish somebody can just understand this once and for all, because this is quite an interesting thing, something that all of us did in high school. If you went to a good high school, you must have encountered this Cramer's concept. So remember, Cramer's is basically a determinant model. So what I'm going to do is to have some numerator matrix divided by numerator matrix determinant divided by the determinant of the base. Listen and listen to me very well. How do I construct my numerator matrix? To construct my numerator matrix, ladies and gentlemen, what I will do is to understand this, that if I'm after x, the column of x must disappear. If I want to get x, what have I said? If I want to get x, the column of x must disappear. I want to put this much better. If I want to get y today, the column of y must disappear. If I want to get x, the column of x must disappear. Where it goes to, I don't want to know. The most important thing is that I have a replacement. Ladies and gentlemen, the first value that I want to get here is the value of x. So the column of x has to go, and then in its place, we shall put the replacement. So then the first column will not be x column. The first column will be the replacement, which is 5 and what here? 1. Ladies and gentlemen, listen again and listen to me very well. These columns can only disappear one at a time. You can't have, in this case here, two people just disappearing like that. It's one at a time. And if column x has disappeared, then the column y has to remain. So what I've said is that if I want x, the column of x must disappear. And if a column of x disappears, the column of y must remain. So y column is column number 2, and I know what the coefficients of column y are. Coefficients here are 1 vis-a-vis minus what? Minus 1, like that. 1 and minus 1. Now the only thing that now you need to do is to come and give us the determinant of these two strokes of my line here stands for determinant. So I would want to see whether there is any student who will be able to give me this determinant very fast. Who will be able to give me this determinant very fast. So determinant of this. How will I get the determinant? I will come and talk over the primary diagonal multiple, 5 times minus 1, minus brackets for the secondary always. 1 times 1. So somebody, Mohammed, is giving me a figure of minus 6, which is the same figure that Melchior and also Samuel are giving me, and also the HP man. And please, it's not lost on us the fact that the determinant of the base, even Catherine, Kate was able to get the same loci like that, yes. So how about the determinant of the base? Determinant of the base, I've done it somewhere here. Unfortunately, I rubbed mine, but I know all of us have got this determinant of the base. All of us have got this determinant of the base. So what is the determinant of the base? Somebody help me out here. Minus 3. So if you do it that way, you'll be able to see that you are getting the same figure that we got using the other method. We'll be able to see, ladies and gentlemen, for the base was negative 3, yes. We'll be able to see that minus 6 divided by minus 3, giving us what figure here? Somebody giving us 2. I know you have not understood this thing very well, but I would want you to take a step of faith. You take a step of faith and get for us the value of y. Get for us the value of y. How do you get the determinant of the base? That I'll be able to explain very fast. Determinant of the base. Determinant of the base matrix. Remember, when we began this thing, we started by defining the base. We started by defining the base matrix. And the base matrix, we said, is constituted there by what here? The coefficients of the unknowns. Here, the coefficients of x and y. Those numbers that come before x and y. So like now here, I can see the first column is 1, 2. And then I can see the second column is 1 and minus 1. So having given me the base matrix, I will very easily give you the determinant. Determinant will be product of primary. Product of primary is minus 1. Minus product of secondary. You take 2 times 1, that gives me 2. That is how the HP man, I was able to get minus 3. That's how I was able to get minus 3. Does that make sense? Thank you very much. I hope it makes sense. I hope it makes sense. HP man, does this make sense really to you? Thank you very much. Now, ladies and gentlemen, is there anybody who has been able to give me the value of y using Cramer's rule? They are telling me that y is 3. That is Garang. We have Hussein, Denzel Bob, 3. Denzel Bob, 3. Please, for the interest of those students, especially the ones who came in a little bit late, courtesy of my mistake. I don't know what happened. And the way I generated today this link very early, I forgot to send the link to our dear brothers and sisters from Summit. Please find it somewhere within your heart to forgive me. After all, we are just revising. I'm so sure these are things that we know. We're just revising. So if they want us to give them the value of y, there is one thing that I know. There is that chorus. You know, at times you may not be able to sing the entire song. You may not be able to sing the entire song. But most of us happens to be knowing what here the chorus is. Like the chorus here will be, if I'm after y, the column of y has to disappear. Thin air. The column of y has to disappear. And remember that these columns here can only disappear one at a time. So if it is the column y that will disappear, then column x, which happens to be the first column, must remain. So in that case here, the first column will be 1, 2. And then y's column disappears. What happens with it up there, we don't want to know. All that we care to know is that there is a replacement, which is what here, 5 versus 1. And then, of course, the most important thing, we'll be able to remember that we want to get the determinant there. And this determinant must be divided by determinant of the base normally works out for every unknown variable. Every unknown variable. So the only thing that we need to do tonight is to ascertain the determinant, of the numerator. We need to come here and ascertain the determinant of the new. So 1 times 1, that gives me 1. Minus 10, that gives me minus 9. And then minus 9 divided by minus 3, that will be equal to what here? Will be equal to 3. Now, ladies and gentlemen, I would want you, number 1, if you have not understood, please to ask a question. Can you even tell me to repeat the entire thing? Ili uzuri wa kuwa mwalimu. Uzuri kazi ya mwalimu hakuna mtu anakuforsia. You always ask for it, just like a military job. Yeah. Is there anybody who has a question now? If there is none who has a question regarding the Cramer's rule, yes, HP asks, why are we having 5 and 1 coming in the second? It's because this time around we want to evaluate y. And when you want to evaluate y, you can see y is the second column. And y is the one that is disappearing, which happens to be in the second column. So you can only replace it at that particular position. So HP man, this nameless, this man is nameless. Have you understood that concept? I'm I'm waiting upon you, or I can again repeat very fast. Remember the first scenario, we had 5 and 1 coming in the first column. Why? Because we were replacing X, and X was column number 1. This time around, we are after Y. And if we are after Y, then the column of Y has to disappear. And the column of Y happens to be column number 2. So the replacement of 5 and 1 can only appear in column number 2. Can only appear in column. You see now the mistake that I'm making. Milka, again, forgiveness. It's a lady. We shall overcome. Well understood. Thank you and thank you very much. Thank you and thank you very much. Now, between the inversion method of getting simultaneous values, X and Y, and the Cramer's rule, which method do you think is better? Which method is better? Is it Cramer's or inversion method? Is it Cramer's or inversion method? Cramer's is easier, yes. Cramer's is easier. And remember, your examiner does not restrict you. He simply tells you to use matrices. It even becomes much simpler when you have got 3 unknowns. You know, with 3 unknowns, as I will be showing you in my next class, with 3 unknowns, ladies and gentlemen, remember all those basic steps that you have got to go through to inverse. Number 1, get the determinant. Number 2, you get the minor element. Number 3, the cofactors. You will take more than 30 minutes doing something in a very, very lengthy way, which is quite useless. If it's Cramer's rule that I know for the 3 by 3, I'll be able to finish that question very fast, but I would not want to do 3 by 3. So Dahil says both are easy, but let's go for Cramer's. No, Dahil, Cramer's is easier, especially whenever you have got 3 unknowns, which I'll be able to show you in my next class. Ladies and gentlemen, here we are, still with this 2 by 2. What if you are given this concept of Markov? Just mentioned there, Markov's model. It's a 1905 model. Don't know how comes those days people really used to discover things. Very, very old model. Nowadays, people don't discover things. They don't discover things. So Markov's model, how do we make use of these simultaneous equations to tackle these? Remember, ladies and gentlemen, the principle of Dr. Markov. This guy was in the physics world. And what he used to do was, if you recall the story behind Markov, he used to take some clear glass, put water there, right? And then what he used to do, of course, with water, he used to come and drop some particles there. Particles of potassium permanganate. Ladies and gentlemen. Edward, these days we are taught to remember. Like now the way I'm teaching you is how do we, not to apply. We shall overcome. So he used to come and put potassium permanganate particles there, which of course could disintegrate into very, very many particles. They could disintegrate into very, very many particles like that. So what were we discovering? That these particles of potassium permanganate, which were purple in color, even in high school we were doing this, were not settling down in a zigzag, or rather, were not settling down in a vertical line like that. No, they were settling down in a zigzag manner. So this could come here, knocks against particles of water, changes direction, so it could fall down in a zigzag manner through a process that we used to call bombardment. That particles of potassium permanganate were knocking against particles of water. What this person wanted to discover, or rather what he discovered at the end of the day, is that water is not made up of a continuous fluid. That water is made up of, ladies and gentlemen, particles that are alive, which are able to move like that. Who can remember this experiment? What was the name of this experiment? What is the name of this experiment? The name of the experiment. There's a name they used to give to this experiment. Who is able to remember that name? We give this person a present. Is there anybody who did this kind of an example, this kind of an experiment in high school? Is there anyone who did this kind of an experiment in high school? I'll not ask you the name. Just if you're able to remember it, even if it's vaguely, but at least you're able to remember that we did this thing of bombardment, particles of potassium permanganate bombarding against. Yes, we did. It used to be called Brownian motion. It used to be called Brownian motion. And please, you should not forget this that easily. If there is one man who used this experiment to make lots of money outside here, one man, just the other day, if you remember Pastor Kanyari, ule wa mbegu ya 310, alikuwa achukua potassium permanganate, anaweka kwa maji ya karai namna hii. So anaambia kama mama, weka mguu hapa, ama ule mzee muoga, weka mguu hapa. Mama anapoweka mguu, ama mzee muoga anapoweka mguu pale, anaona maji imekuwa damu. Mama anasema uoi, sasa pasa anakuambia wewe weka 10,000 namna hiyo. So no pastor, na alifika form 2. Alifanya tu experiment kidogo, akajua Brownian permanganate. You never heard of it. What do you mean? Then you may not have done these sciences, eh? Okay, but now we have what we call Brownian motion. Now, ladies and gentlemen, this Brownian motion, why should we discuss about Brownian motion in a business class? Remember, Dr. Markov went ahead and said that this physical motion can also be borrowed, ladies and gentlemen, and be used in the business world. Why? Because of how customers behave between competitors. You know, there are very few customers who are loyal. Like myself, I'm very loyal to KTN. KTN news only. KTN is for news only. But you see, after some time, normally what happens? When I'm here, or rather even before KTN, I would want to throw my eyes, in this case here, to Citizen. And perhaps in this case here, watch this young kid called Maria. Right? So in essence, what am I doing? Natanga-tanga. Unaona kutanga-tanga? Hiyo ndio inaitwa Brownian motion. Brownian motion. And this is what came and they gave birth to what we call the transition matrix. The transition matrix. Transition matrix. In Brownian motion, you know, like there is a time they brought some question of Markov. You remember that question where taxis were moving, some taxis were moving from Westlands, others going to Eastlands, others going to town CBD. So taxis were moving from one location to another like that. So one day after that particular exam, a student called me, told me, Mwalimu, this keyword this time around was very difficult. So I asked the student, what type of questions did they give you? The student told me that they gave me a question where I could not really comprehend. The taxis were running very fast from CBD, and I knew straight away that that student had not gotten that that was a question on what year? Markov. Because Markov, transitioning, Markov, you must be told customers are moving from A to B. And Markov, like this question that came just the other day, where patients were being taken from ICU to high dependency unit. Some others were moving from HDU to general ward. Once you hear of movements of subjects of analysis from one state to another, then straight away you are handling a Markovian question. You are handling a Markovian question. You are handling a Markovian question. Because many a times students get these kind of great questions, but because they don't know where those questions belong, they don't know whether it's a matrix question, they end up in this case here getting a Z, But the very best way of remembering Markovian questions is to remember what I've just told you. That on a Markov questions, you'll always hear things like transition, movements of subjects of analysis from one state to another state, to another state. So I have to give you that little story so that in future, you'll never ever forget how to identify a Markovian question. Ladies and gentlemen, now with that background, I would want us to look at something very easy there in form of an illustration. So in our illustration, you are given T. You are given matrix T. We are told here T equals 0.3, 0.7. We are given T equals 0.3, 0.7. And then we have 0.6, 0.4 like that. And then, ladies and gentlemen, these guys have gone ahead to give me the initial vector. Where they have told me that vector 0 is 0.45, and then we have 0.55. So remember, to us here, T stands for the transition matrix. T stands for the transition matrix. T stands for the transition matrix. And then, of course, this is the initial vector. VO stands for the initial vector. And then, ladies and gentlemen, we are required to do a few predictions here. You can see these are 2 by 2. I'm still working on 2 by 2 because now I can't introduce a 3 by 3 matrix within the time limits given. So, ladies and gentlemen, required, I want somebody to run with this ball and give me vector 2. Vector 2, this could be after the movements. How do we expect, where do we expect these customers here to be in the second year, at the end of year 2? So I would want somebody to come and give me vector 2. And I would want to pause a little bit. So here, they want us to make predictions. Like they have given us vector 0. They have given us the transition. The T stands for transition, and then they want us to do the prediction. So how do we do this? This is very easy, ladies and gentlemen. Remember the Markovian chain link. The Markovian chain link normally starts from vector 0. Remember the assumptions of Markov. We normally begin from vector 0. And after vector 0, we'll go to vector 1. Then from vector 1, we can now go to vector 2 and other vectors, moving using that particular word here, chain. So there is no way you can predict directly from vector 0 to vector 2. From vector 0, we can only get vector 1. Vector 1 can only give birth to vector 2. So what am I saying? Even if the examiner has asked me to get vector 2, there is no way I'll be able to jump like that. Markov systems don't allow that. Don't do that. So what I need to do is to come and give them vector 1. And how do I get vector 1? I'll come and take vector 1 can only be obtained from vector 0. What I need to do is to take vector 0, I multiply this with what here? With the transition. So remember here, you have to begin with a vector. Therefore, ladies and gentlemen, my vector 1 will be equal to vector 0. Already I have it. It's 0.45, 0.55. And then I'll come and multiply this with the transition matrix. I'll multiply this with the transition matrix. The T matrix here is 0.3, 0.7, 0.6, 0.4. So, ladies and gentlemen, with this information, I should be able to do my multiplications very easily. Remember, when I'm multiplying, it's all about Roman Catholic. It's all about row and a column. So what do we have here? It's 0.45 times 0.3. First one's multiplied plus second one's multiplied. So first one's multiplied plus second one's multiplied. Could you kindly give me this very fast? Vector 0, vector 1, I mean, Roman Catholic. You run down the ditch. Now people are becoming tired. Please give me this first one here. What do we have? Somebody there. So we have 0.465. That's according to Dahir. We have 0.465. According to Dahir, vector 1. The first component here is supposed to be, this vector 1 is supposed to be 0.465. How about the second component? How do I get the second component? To get the second component, I will take this row by the second column. Hope they're able to follow. I hope they're able to follow. I hope they're able to follow. I hope they're able to follow this row by the second column. How do I do it? 0.45 times 0.7 plus 0.55 times 0.4. Please give me a figure. Please give me a figure. Aha, we have Denzel giving me 0.5, 0.535, like that. So that is vector 1. That's vector 1. Now, having gotten vector 1, we can very easily go to vector 2. Very easily, comfortably, we can go to vector 2. How do we get vector 2? Vector 2 can only be born from vector 1. And what we need to do is to transition, is to change vector 1. So what we need to do is to take that vector 1 times t, the transitioning factor. So times t like that. Vector 1 is 0.465 to 0.535 multiplied by our T matrix. Multiplied by our T matrix. How will this T matrix look like? So we have our T matrix, ladies and gentlemen, which is 0.3, 0.7, we have 0.6, 0.4. So right there and then, what I'll need to do is to take row 1, column 1. High school used to call it, you running down the ditch. Running down the ditch. Running down the ditch. But don't forget the order. It is first one's multiplied plus second one's multiplied. First one's multiplied plus second one's multiplied. And then you give us an answer. You give us an answer. So we have Hussein Wario giving us 0.46, 0.46, 0.5, and then we have 0.46 vector 2, 4605, and then we have 0.5395. Thank you, and thank you very much. So like now you can see straight away from where we began from, ladies and gentlemen, the first, like here for vector 1, the first company gained more ground, had a bigger, it started from 0.4 something, so it has gone to 0.46. So market share changes, but again, remember that this market share does not keep on changing forever. Does not keep on changing forever. After some time, ladies and gentlemen, these systems here will do what here? They will stabilize. They'll hit a plateau. They'll hit a point of stability where we don't expect, ladies and gentlemen, in mature markets, we don't expect things to change anymore. Right? Where in this case here, we have what we call loyalty, where you can't have, for example, a student moving, for example, this is just an example, a student moving from RCM, goes to Summit, for example, from Summit, section 4, he goes, for example, to Visions, right? So it keeps on moving. No. It is a time a person will realize that even if this person is a little bit disabled here and there, even if there are issues here and there, heri nyumbani. Na mtu anakaa nyumbani 100% with all their problems. So once we reach that level, then we know that we have hit what we call a steady equilibrium vector, and I would want to pick it from there in my next session. Today I'm the one who is teaching advanced Excel and financial modeling. I need to prepare my files, and then I send them to my students early so that I don't get any problem that time. So I seek your indulgence as we go for prayers. Please pray for us. We shall overcome. Thank you very much. So unless there is any burning question, please allow us to end there and continue watching those videos. Like now, if I were you, I would go there on that platform, check on these videos. I know, of course, they're mixed up a little bit. That's what I've been working on today. I want them to follow some order. But please just continue watching them, especially for what here, the past paper questions. So thank you very much. Network analysis. I've done network analysis, Denzel. I've done network analysis. Denzel is a student at Summit. So there is no problem. What you need to do, the students of Summit, you can, I know your class rep is Charity, so you can just do a summary of the topics that you feel were not covered, and then I'll be able to know how to tackle them, The other students that I am normally with at the RCM's WhatsApp, also if there are topics you feel that you really need, we brush on them very well, better. I'll not mind if I can have that list. Otherwise, now we have to be very serious because we know at the end of the day, the corona cases are coming down and down, right? After that expose, they're coming down, and like today, they were only 83. So meaning that before the end of this month, we could be opening our colleges. And of course, I don't advocate that you go back to classes, physical classes, no. What I want you to see is that once these colleges are opened, of course, these are examination centers. So the next thing we expect is to do an exam in November. We shall be revising everything. Actually, that is it. HP man says we shall be revising everything. We were to cover small sampling today. I did a video. I'm surprised how comes you guys haven't gotten this video. I did a video of small sampling. Or linear programming is missing, then that I'll be able to put because I've done linear programming questions, very many of them.